Hi, this is Asing. You are now watching Asing Math TV. Today, we'd like to share the inferences about the difference between two population means. To conduct independent sample t-test by using SPSS, we have to make sure that the measured variable enter in the same column for both populations, and we need a column for the grouping variable. To define the grouping variable, we can go to the variable view. Under the values, click on the button, and we can let 1 be equal to country X and 2 be country Y. And we notice that the number of observations for each group may not be the same. Let's try the test. Go to Analyze, click on Compare Means, Independent Samples t-test. Move the variable of interest to test variable. Move the grouping variable to grouping variable. Define the groups. We have 1 to represent country X, 2 to represent country Y. Make sure we use exactly the same value as the label. Click on Continue. Click on Options and check for the confidence intervals if needed. Click on Continue and click on OK, and we should obtain the result that we want. To change the number format, for example, the decimal point, double-click the table, select the number, right-click, look for cell properties, and we can go to Format Value and increase the number of decimal places. And so for the second table, double-click, select the numbers, right-click, cell properties, increase the decimal point, as we can see here. Based on the problem, our intention here is to test whether the average height of female in country X is less than that of the country Y, which means that we should conduct a left tail test. Since it's one tail, which means that we should take alpha instead of alpha over 2. And with the degrees of freedom n1 plus n2 minus 2, we should obtain degrees of freedom 37. We are able to compute the value by using SPS. Let's make use of a new data book. Make sure the data view is not empty, otherwise we are not able to compute. Let's go to Transform Compute Variable. Since we are looking for the test statistic t, then we type t. For the numeric expressions, look for the inverse distribution function. What we need here is the t function. Up, first question mark is the significant level 0.05. We are not going to take 0.05 over 2 because this is one tail. And what we need here is degrees of freedom 37. We should always bear in mind that SPS use less than cumulative. Since this is to the left, which means that it's a left tail test, and we can take the significant level directly. However, if let's say this is right tail test, which means that we should take the complement of this value, or we just modulus the value after we have computed the value. Since this is left tail and we should obtain negative. Left tail test, the critical value must be negative. So no wrong, we can click on OK. If right tail, we should take the modulus of the value. From here, we can see that the critical value is negative 1.6871. And for the test statistics, as we can see, according to Levin's test for equality of variances, the p-value is greater than the 5% level of significance, which means that the assumption of equal variances is not rejected, which means that when we conduct the t-test for equality of means, we should refer to the statistics that belongs to equal variances assumed. So which means that we should take this test statistic instead of this value. This is for equal variances not assumed, but the significance is greater than, so we shouldn't reject this assumption, which means that we should take all these statistics. From here, we can see that the test statistics is equal to negative 2.8945, and the degrees of freedom is 37. The mean difference is simply by using the first mean minus the second mean, and for the standard error difference is computed by using the pooled standard deviation, since equal variances are assumed. From here, we obtain that the test statistics, which is less than the critical value, which means that we should reject the hash null at alpha 0.05. In other words, there is sufficient evidence to conclude that the average height of female in country X is less than that of the country Y. We could also make use of the p-value approach. From here, since the p-value that we obtain is for 2 tail, recall that we conduct only for one tail, which is the left tail, which means that we should take the value divided by 2 and obtain the correct p-value, which is only for one tail. And from here, we compare with the significant level, we can see that it's less than that, so which means that we reject H null as well. If we reject H null, which means that there is sufficient evidence to conclude the same thing. If we are asked to verify the values for the 95% confidence level, what we need here is the t-value, since the mean difference we already verified by using the first mean minus the second mean, and this is the standard error which using the pooled standard deviation. And for the t-value, since this is confidence interval, which means that we should take alpha over 2. Let's go back to the data view. What we need here is to compute the value, but we change to alpha over 2, which means that we should take 0.025. Click on OK and we should obtain the value. From here, we can see that the value is now negative 2.03 or negative 2.0262, rounded to the nearest 4 decimal places. Substitute everything, use calculator, and we should obtain exactly the same as the confidence interval provided by SPSS. To better illustrate the statistics that use under equal variances not assumed, we should assume that the Levin's test has rejected the hypothesis where equal variances assumed. From here, we can see that test statistics are different for these two assumptions. This is because they are using different formula, as we can see here, and the degrees of freedom we should compute by using this complicated formula. If we compute manually, we should always round down the value, but we should bear in mind that SPS always take decimal degrees of freedom. So if we compute the value manually, we might obtain the value that is slightly different from what provided by SPSS. This one we should take note. And with different degrees of freedom, we should have different critical value as well. To compute, also make use of this new book. We are going to go back to transform compute variable, and this time we should change to 32. Remember to change the significant level as well, since this is the left tail test, which means that it's 1 tail. Do not take alpha over 2. Click on OK and we should obtain the t-value as we can see here. The t-value should now be negative 1.6939. And we need less than region. From here, we obtain the test statistic by using different formula, and this is supposed to be equal to negative 2.8709. Again, the test statistics is less than the critical value, which means that we should come to the same rejection and conclusion. And so for the p-value approach, again, we should take the value divided by 2 and obtain the p-value, and as we can see, also less than the significant level, so which means that we have the same rejection and conclusion. And for the 95% confidence interval, we should bear in mind that since SPS uses decimal degrees of freedom, which means that the value that computed might be slightly different from what we compute manually, since we use integer 32, but SPS used 32.729 something. If you want to follow SPS, since we have SPS here, we can also compute the value since we are able to input decimal value. Remember to change to 0.025 since this is for confidence interval, and what we need here is degrees of freedom 32.7292. So we should type 32.7292. Click on OK and we should obtain the t-value, which is slightly different from what we have here, as we can see. Okay, that's all for this video. Thanks for watching. Hope you liked it. See you.